All right. Hi, guys. So what we're going to be talking about today, so we already know how to find angles or angle measures and arc measures if you've got an inscribed angle. And we know that the inscribed angle is half the measure of its intercepted arc. We also know how to find the measure of an arc or an angle if it's a central angle, right? And those are equal. So if this arc is 60 degrees, that means my central angle is also 60. There's another situation that you can have, and it happens to be when you have tangents, and chords, and secants. Okay, so a mixture of all the other different guys we can have. So what I've done here is I've put the three different theorems that have to do with, these are the last ways you can find angles, okay? So you've got three different theorems and then we're done, okay? So you have to have all these memorized. I think it would be a good idea to make flashcards, really nice ones, because even though they're kind of simple now and they're all separate from each other, when you get to a big problem, it kind of gets confusing, all right? But anyway, let's get these guys done. The first theorem we're going to talk about is a tangent chord theorem. And what this is if you have yourself a circle, so draw a circle, and actually, might as well draw a circle in the other one too while we're at it. Okay, so you've got here two circles. All right, let's do the tangent chord theorem. So for the tangent chord theorem, you're going to need to draw a tangent. All a tangent is it's a line that intersects the circle at exactly one point. And then let's just draw in a chord here. I'll call my chord AB. Okay. The tangent chord theorem allows me to find the measures of this angle. We'll call this angle angle 1, all right? And let's see, I'll draw it in black, this angle here, and I'll call that angle 2, okay? And what this theorem says is that the measure of angle 1 is equal to 1/2 the intercepted arc. And in this case, it's this arc here that it creates. See that? So it's equal to this green arc that I just colored in. And in that case, it's a minor arc, so I can name it AB. Okay? So if that's the case for measure of angle 1, what do I know about the measure of angle 2? Okay? It's also going to be half the measure of the intercepted arc, but since this is a major arc, I need to tag in another letter. Okay, so measure of angle 2 is 1/2 the major arc ACB. So this black arc. Okay, and you have to make sure you name it, like connect the dots, ACB. Easy? Okay. So the next one is if you have angles inside a circle. Usually this is with two chords intersecting inside a circle. Again, two chords intersecting inside a circle. So let's draw them. Let's see. Let's call this one DR. And then I'll draw another chord. He looks good. And I'll call him AW. All right. So here I have two chords intersecting inside a circle. We'll call this we'll call this angle 1. All right. In this situation, we know the measure of angle 1 is equal to 1/2 again. All of these have a 1/2 in the formula. They're just different formulas. 1/2 the sum. So the sum means add the sum of the intersected arcs. And now it's its arc and the arc of the angle vertical to it. So I'm going to be adding the yellow arc and the green arc, okay? So the yellow arc is WR in this case, and the green arc is DA. So the measure of angle 1 is equal to 1/2 the sum of those two guys, all right, where we have WR, which is my yellow arc, plus DA, which is my green arc that I have drawn here, okay? If I have angle 1, this isn't part of the theorem, but just so that we can talk about it, I also know the measure of angle 2, right? These are vertical angles, therefore they're congruent, okay? So that's that theorem. The last thing that happens, so inside the circle we're going to add when you have two chords. Now, if you have situations where you either have a secant and a tangent or two tangents drawn to a circle, so this was a secant and a tangent, the first picture, angle 2 is created by two tangents, and angle 3 is created by two secants because they intersect the circle in 2 points. these are outside. And all of these formulas have to do with, the difference. So you're going to be subtracting things, okay? So if it's inside the circle, you're going to be adding. If it's outside the circle, you're going to be subtracting. And here are the formulas, and they're all the same, all right? And I'll write them in the same colors here. So we know in this case, measure of angle 1 is equal to, all the formulas have a half in them, but since it's on the outside of the circle, we're subtracting 2 arcs. And the 2 arcs that I'm going to be subtracting are BC, measure of arc BC, and I'm going to subtract from that the measure of arc AC. Okay, so the red arc minus the blue arc. Okay, and the formulas are the same for the remainder of these diagrams here. They just look a little different. All right, so for this next one, we've got here the measure of angle 2 is equal to 1/2. Since it's on the outside, it's subtracting. And in this case now, it's measure of arc PQR, that's my major arc, the bigger arc, minus the measure of my minor arc, which is PR. All right, last but not least, measure of angle 3. Can you guess what the formula is going to be? This should be a W, by the way, and this is a Z. You can't see it. This one, same difference. 1/2, you're subtracting 2 arcs. What are the 2 arcs I'm going to put in that formula? XY is the bigger arc, and then I'm going to subtract the smaller arc, which is WZ. If you subtract them in the wrong order, say you do WZ minus XY, you'll end up getting a negative number. It will still be the right number if you take the absolute value of it, if you make it positive, okay? But that's why I keep on saying the red arcs in this case are the bigger arcs. You always do the bigger arc minus the smaller arc, all right? So what I'm going to do now is work through a couple of examples with you, and then you'll be able to try some on your own. Okay, so let's do this one. This one is created by a chord and a tangent. So there's my tangent, and here is my chord. So I know the measure of angle 1 is equal to 1/2 the intercepted arc. And in this case, the length of that intercepted arc is 210. You need to show the formulas on the regions. If you just write the answer, if this was a 2-point question, you get a 50%, even though you know the right answer. All right. So 1/2 of 210 is 105 degrees, and that's the measure of angle 1. Now, they want the measure of arc RST. So if I connect it, RST goes like this, and again, it's a tangent and a chord problem. So I know well, we have to think about it now this way. We're going the other way. We know the angle, which is 98, is equal to 1/2 the measure of the intersected arc, which in this case is measure of arc RST, right? So how I would solve this is just double both sides, right? Because the multiplicative inverse of 1/2 is 2. So to get rid of the 1/2, if I multiply by 2, or 2/1 on each side, these will go away, okay? And 2 times 98 is 196, and that's equal to the measure of arc RST. Why don't you try to get the measure of arc XWY? This is a Y, and let's put the W here. Pause the video and then press play when you're ready. Okay, you could have done this one a couple of different ways. If you see what I did here is I said, since this one angle is 80 degrees, and since the tangent is a straight line, I know these are supplementary, meaning this guy on the bottom angle has to be 100, okay? And since the intercepted arcs are twice the length of the angles, I just doubled it. So 100 times 2 is 200, all right? The other way you could have figured it out is if you doubled 80, that would give you the measure of this arc. So 80 times 2 is 160. Now to get the yellow arc, I know there's 360 degrees in a circle, and 360 minus 160 is 200 degrees. So either way is acceptable. On the back, I just have a couple of practice problems that I will work through with you. So these are kind of like an assortment of different things you'll see. Let's do 4 and 5. So here I have inside the circle, and inside the circle means you're going to add the arcs. Oops, inside. So it's the sum, okay? So measure of angle x is equal to 1/2 the sum of its intersected arcs. And in this case, that's 89 plus 63. Okay, 89 plus 63 is 152. So in this case, the measure of angle x is equal to 1/2 of 152, which is 76 degrees. Remember, always set up your equation. The angle is equal to, and then write your formula. If you don't, you will not get full credit on my test or on the Regents. You have to show your work, okay? In this case, again, they want me to find the angle. It's outside the circle, so it's a difference. So in this case, the measure of angle x is equal to 1/2 the difference, or subtract, the intercepted arcs. And in this case, the big arc is 78, and the little arc is 42. 78 minus 42 is 36, and 1/2 of 36 is 18. So x is 18 degrees. All right, this one. Now they want me to find x. Okay, and we've got two secants and the angle is outside. So when we have outside, we know the formula is difference, so you're subtracting. And I know the measure of the angle, which in this case is 34, is equal to 1/2 the difference of the intercepted arcs. And you always do the big arc first. So the big arc here is 3x minus 2. Okay, and the small arc is x plus 6. Now I'm going to put it in little parentheses. The reason being is because when you're subtracting, this is a great Regents question. If you don't put it in parentheses, you might forget to distribute the negative to both guys. Okay, so make sure you put in parentheses because you need to change the sign of both. 3x minus 2, when I distribute that negative, it turns into minus x minus 6. Okay, so that gives me 1/2. 3x minus x is 2x. Negative 2 minus 6 is negative 8. And this is still equal to 34. And now it's a simple algebra problem. You have a couple things you can do. You can either distribute the half or multiply both sides by 2. I'll distribute the 1/2. And I'll bring it up here. So I have 34 equals 1/2 of 2x, which is x, minus 1/2 of 8, which is 4. And when you solve for x, you get 38 degrees. Okay, this is the last one, and then you can do the final guide on your own. Now, again, it's an outside, so I know the measure of angle x, or x in this case, because it's the exterior, is equal to, since it's on the outside, it's 1/2, and it's the outside, so it's a difference. Now I need to subtract things. I know this big arc, if I highlight it for you here, is 247, but I don't have the smaller arc. How can I figure it out? Hopefully you're answering my question. To figure out this little arc here, what do the arcs have to add to? 360, right? So to get the green arc that I just drew in, I have to do 360 minus 247, and that gives me 113 for the measure of that green arc. Now I can go through and do the problem. X is equal to 1/2 of 247 minus 113, which is 134, and 1/2 of 134 is 67 degrees. Okay, so please go through, guys, and do A, B, and C down here. And I will put the answers up here for you. Make sure you're writing your formulas and show all work to receive full credit. When you're done, hit play so you can see the answers, but I will not show you the work. All right, guys, and here are the answers. Make sure you have all of them correct. If you didn't get them right, go back and rework it. Look at the notes that I gave you at the beginning of this lesson, okay? And I will see you tomorrow.